right here at the beginning. So our very first vocab term we're going to go through, and you're going to pause and make sure you have enough time as I go through these. A transformation is a change made to the location or to the size of the figure. So these are all different transformations. A transformation is a change made to the location or the size of the figure. An image is the new image is formed by the transformation. So when we move something or we make it bigger or smaller, it's now called an image. Just like an image in your camera, it's everything that happened that was in that real life situation was shrunk down to a picture. That's the image. A translation is a transformation in which each point of the figure moves the same distance in the same direction, and this is also known as a slide. So when you hear translation, you could also think slide. Again, make sure you're pausing when you need on these. And then a tessellation is when you're using a translation to cover a plane. I don't know why my cover disappeared. Using a translation to cover a plane with a repeating pattern of one or more shapes. And very important to remember is that a tessellation has no gaps or overlaps. So I just Googled tessellations really quickly, and a bunch showed up. So here's some tessellations right here. It's the same pattern or a couple of different patterns that have been basically translated. They've been slid over, and there are no gaps or overlaps. Now I want to show you one. Here's a cool one with trees right here. Even though one's only colored, that's just a tree upside down. Okay, this is not a tessellation. And when I Googled tessellation, this came up, and this is incorrect. Although, because it depends on how you're looking at it, because there are gaps here. There are no overlaps, but there are gaps. If this was the pattern that kept repeating, that would be fine. I would just need to continue it on there. So it kind of depends on how you look at it. If these are gaps here, then that's definitely not a tessellation. If this is a pattern that's repeating, that's okay because it's one or more items. Okay, but that gives you an idea of tessellations. You may have done those in art class before. They're lots of fun. And so we're going to move on to example 1. Example 1 says, for the diagram shown, describe the translation in words. Okay, so we want to know, our original was A, and my new one is A prime. There's actually a little mark there. It's like an apostrophe, A prime. That's what's right there. That's the new one. That's the image. So we want to know what happened from A to get it all the way over here to A prime. So it says, think of moving horizontally and vertically from a point on the original figure to the corresponding point of the new figure. For instance, you move how many units to the right? We're going to do to the right first. How many units over did we have to go until we were on this line here? 1, 2, 3, 4. We moved 4 units to the right. And then once we're here, we're pausing, and then we go up how many? 1, 2, 3, 4, 5. 5 units up. Our new point right there is -3, -2. I'm sorry, our old point was -3, -2. Our new point is 1, 3. So that's just a description in words of what movement we just did there. Let me zoom in just a teensy bit here. Okay? So that leads us into coordinate notation, which is on your next page here. Coordinate notation. Okay? So you can describe a translation of each point, your x, y, each point is in the x, y form, of a figure using the coordinate notation. So I have to add something to the x and add something to the y. So we add a to the x, b to the y. We're just showing that it could be a different number each time. We also say it's addition, but certainly we could think of it as subtraction, but subtraction is the same as adding a negative, so that's why they describe it as addition every time. Okay, it says A indicates how many units a point moves horizontally, and B indicates how many units a plot moves vertically. Vertically. Move the point X y. To the right if a is positive, and to the left if it is negative. And we're going to move the point up if b is positive, and down if it's negative. Okay? So if we are at x, y, we're going to look at this one right here. This is our prime. See where there's the little quotation mark, the little hash mark up there above the a and the b? So we are going to move this a to here and this b to here. So we're going to describe this in general, what happened. So my point x, my first x coordinate, we can just look at one of them here. I'm at -3 and I go to 1. So how do we go from -3 to 1? We move over 1, 2, 3, 4 units. Now let's make sure that that description works for the b's. Is -1 plus 4 3? It sure is. Okay, and then we'll look at the y's. This time I'm going to look at this one. It doesn't matter which one you look at. It should be the same for both. I just want to prove to you that I can look at both. So 2 ends up going down to 1. So we're taking that y term and we're subtracting 1 from it. So is that what happens here? -1 minus 1, is that -2? Yep, -1 plus -1 is -2. So that's my coordinate notation of the movement that just happened there. So you're going to need some colors for this next example because we're going to have a triangle and then an image of that triangle. So I'm going to start off with a certain color, and let's read the directions. It says, draw a triangle ABC with the vertices, and it tells you where point is. Point A, B, and C are. So go ahead and draw those in. I'm going to label them A, B, and C. And then I'm going to use a ruler or a really straight hand to connect those points. So that's pretty good. Okay? So that's that one. It says, then find the coordinates of the vertices of the image after this translation. For all the x's, you're going to add 4, and all the y's, you're going to subtract 5 or add -5 if you would prefer to think of it that way. And then you're going to draw this new image. Okay? So I'm going to do this in another color. I'm going to pick orange right now. And it says, solution, so it's talking us through. First, draw triangle ABC. Then translate triangle ABC. Add 4 to the x. That's where that came from. And subtract 5 from the y coordinate of each vertex. Okay? So you're literally right now, my new A, B, and C, see it's A prime, B prime, and C prime. You're literally going to add 4 to the x's. I usually do all the x's and then go back to the y's. So add 4. So -2 plus 4 is 2. -1 plus 4 is 3. 0 plus 4 is 4. On the y's, we're going to subtract 5, or you can think of it as adding -5. 1 minus 5 is -4. 4 minus 5 is -1. And 1 minus 5 again is -4. Okay? So now, got something in the wrong spot here, don't I? Why did I see a -1 here? I saw -2, -1. Okay, so here's what we're going to do. I'm going to put a negative sign right here, since that's what I've already graphed. And if you had your graph match mine, then you got the same problem. If you kept it up here, then your graph looks slightly different. Yours graph actually looks like this one. Either one's okay. I'm just going to switch that guy right now and plot my new points. So if you were with me, you have this. I'll show you what it's going to look like if you weren't with me, if you did it the right way without my little brain problem I had there. So 2, -4, 3, -1, and 4, -4. Not going to work because, well, yeah, that's okay. I have my original picture there. So I'm going to go back and fix this guy here. So this is 2, -4 is A prime. 3, -1 is B prime. And C prime is right here, 4, -4. Okay. So here's how I caught my mistake. Not just because I had it on another piece of paper, but because the shape should have just slid over. It should not have changed its shape. This is a totally different shaped triangle than that guy, so I knew I made a mistake. This is what it should have looked like. This guy got shifted. Okay. He got shifted over 4 and down 5. That's the right answer. So, if you made a mistake like I did, I said you didn't have to change it. I didn't mean it. You're going to have to go back and make your AB line a little bit differently so that it looks better. Okay? But hopefully, it's the easy fix on yours. So, this is a really good learning opportunity because our pictures should look the same. So to finish off our notes here, what's going on with my computer? Why are you frozen? There we go. To finish off our notes here, we moved 4 units right and 5 units down. Okay? All right, so let's look at the next page of your notes. You're going to do the same thing on this one. You're going to pause it. You're going to do better than me and not make a mistake. You're going to pause it, and you're going to see how you do on this. You're going to need to write out the new points. So you should have over here off to the side a little notation like they did over here. See how they showed A going to A prime, B going to B prime. So you, at minimum, need my P prime of my new unit, my Q prime, and so on. So just to get you started here, we're doing a quadrilateral this time. What does that mean? Quad. Yep. 4 sides. And we're going to add 6 to the x's and add 5 to the y's. So if I just do the first one for you, that would be 2, comma, 4. And I go to 2, 4, and I would make my point there for P prime. But you'd also have P on this graph as well, okay? So go ahead right now, pause it, and you should have the old quadrilateral and the image on your paper when you come back to see how you did there. Okay, so here's what you should have had. And then tell me the quadrant. What's the quadrant of the original? It's green on my paper. What quadrant is that? That's quadrant 3. 1, 2, 3, 4. We label it with Roman numeral 3. And then the new one is in quadrant 1. And that's a Roman numeral as well. Okay, example 3 down here. Go ahead and read the question to yourself. Pause the video. Answer by plugging into the blanks there to tell me whether or not those are tessellations. Can you make a tessellation from those figures? So pause, do that, and then come back and see how you did. All right, you should have gotten that in A, you can't translate it to make a tessellation because there will be gaps and overlaps. In B, you can translate it because there are no gaps and no overlaps. It's not a very exciting tessellation, but it is one nonetheless. The reason why this is different as opposed to the one on the little iPad that I had shown you before is because it just said this shape. It didn't say this shape and this shape. So there's no way to get these to match up. It either has a gap or an overlap. Okay, so that's the end of the notes for this section, and you are on your way to some practicing of translations on the next page. Good job.